Welcome to Chem Help ASAP, and thank you for watching this video. This is a reaction video or a commentary video on a not so recent video from Modern Goldsmith. So I've actually done a reaction video on part one of this video. This is where he's isolating different metals from this lump of kind of just a metal mass. And he's already done a video about isolating gold. And this reaction video is about how he isolates the silver from that lump. And you might say, silver's not as interesting as gold. But the chemistry is every bit as interesting. So we're going to talk about the chemistry of this process as Modern Goldsmith walks through this process. Now this is a little bit difficult because there's a lot of music in this video. So I will have Modern Goldsmith muted for a large chunk of this video, so to avoid copyright issues. But I'll try to provide narration on top of what he has. So let's go ahead and get started on this this isolation or isolation of silver from this lump of metal.
In my last video, I extracted 24 karat pure gold from this blob. In this episode, we turn our attention to silver.
Okay.
When refining the blob, I was left with a lot of silver chloride. The mission for this video, convert that silver chloride into pure silver. Originally, I wasn't even planning on trying this, but part one was a massive success and so many of you asked for it, so here it is. That video is currently sitting at over 2 million views by the
2 million views. It's actually as of the time of this video, it's over 22 million views. So successful indeed.
way, which I do believe a toast is in order. To chemistry. And
Jesse.
Okay, I don't know if you caught that. Let's listen to that one. Listen to where he says Jesse.
To chemistry. And
Jesse.
So he dubbed in Walter White's voice in there. That was very slick.
Yes. Yes, science.
it's time to cook. If you are back for part two and still haven't liked and subscribed, I invite you to say my name. And
so I'm going to pause there. Please do check out his work, not just my video, but see the original. I'll have a link to it in the video description. This is the point at which I'm going to go ahead and turn off the audio because there's more music coming. So I'm going to try to silence that, and we'll just move forward from here. And in addition to muting, I had to cut an advertisement out. So here he's unpacking his material. This is silver chloride that he filtered out of the reaction. It's a solid, and it's according to his audio, this has been 6 weeks since he did this. So he just put it in a bag in plastic wrap, not plastic wrap, but bubble wrap in a box. So it's just been sitting there wet and soaking. And there's filter paper in there. It's just a gooey mass, and he wants to get rid of that filter paper. Actually, if you left this open to air dry, it would flake off the paper probably pretty easily, but it's not dry and it's not flaking off. So, you know, he's got a problem. He's got to get rid of this paper now. So he's just going to throw all this together. I will comment, so you see that color? I said this is silver chloride, and it is silver chloride, but it's not very clean. There are a lot of different impurities in here. There's likely copper. Copper has a blue color. It doesn't look blue, it looks green. It's green because there's also probably some residual orange-yellow solution from the orange juice that we saw earlier, which was a callback to this orange gold solution he had. So I think that's why it looks green. It's a mix of both the orange-yellow of that gold solution and the blue from the copper. So it makes it look green. Regardless, he's got to get rid of all that before he tries to get pure silver from here. So his first step is to get rid of the paper. So he's going to treat this with hydrochloric acid. And I'll pause it just to have you look at that solution he's pouring in there. It's yellow. Yellow is not the color of hydrochloric acid. Hydrochloric acid is typically colorless. Although when you store bottles of concentrated acids, including hydrochloric acid, sometimes that vapor leaches into your cap. And sometimes caps have liners glued into them, and the glue will actually dissolve and kind of drip down and ooze down into your acid, and that'll cause some discoloration. But hydrochloric acid is not generally a yellow color. Regardless, this acid should help to dissolve this paper. And it will not dissolve his silver chloride. And he's going through some of the chemistry here. I don't agree with every bit of his chemistry discussion, but the point is he's got to get rid of the paper, and he wants to leave the silver chloride as a solid. And when things are slow, and this looks slow, what can you do? Well, sometimes you heat things up. And so he's stirring this around, and I think seeing that it's going nowhere fast. So let's turn on that burner and get this warm. And there we go. Now it's cooking. He's dissolving down the paper. And we got to see what's happened. That's his silver chloride. Let's let it cool down. It's going to settle out. The silver chloride is fairly dense. So let's pause there. So he's got this darker solution on top, and who knows what's in there. It certainly has a lot of acid, but there's other stuff in there too. In this middle layer, it's not as settled as the bottom layer, so this is likely bits of paper that still hasn't dissolved. And on the very bottom is the more dense silver chloride, and that's what he's interested in. He's got to get rid of this paper. So what are we going to do? Can't wait to see. Cook it some more. So we're just going to heat it up some more. It seemed that the cooking seemed to help. So if a little bit does good, then do some more. And there we go. Now it's settled down. You can see if there's a paper layer there, it's pretty small. So this is looking really promising. Let's go ahead and move forward. So he's going to take it off. He's going to try to pour off that top liquid because he doesn't care about that, and leave behind the solid in the bottom. It's very hard to do this because these fine solids, as soon as you move that beaker, those fine solids, they kind of get stirred up a little bit. And then you're not just pouring off the liquid, you're also losing some solids. So this is kind of a tedious process. He's going through a series of decantations. He's adding fresh water to rinse off the acid, trying to pour off that excess acid. And you can see he's making headway, but he's definitely getting solids around. So here he kind of shows sort of the full array of what's happening. He has silver, fairly nice looking silver chloride. Silver chloride is not green, but it is kind of this dingy, almost white color. And as you can see in his transfers, he's losing a little solid in his transfers, but as he rinses off the copper, and maybe a little gold, he's getting that solution. So he's making headway. Another way to do this would be simply to filter the solid and then do successive rinses in a funnel like a Buchner funnel. But he's going to get his task accomplished here. So continue these transfers. Really tedious stuff. This is the kind of stuff that drives you crazy because every step looks better, but it takes a long time to get it to where you want it to be. So transferring. He's generating a lot of liquid waste. He's pouring his waste. He keeps this in a stock pot. And it's funny because there's another gold refiner who will get mentioned at the end of this video, Sri Tips. And he always calls his waste bin his stock pot. And I don't know where that comes from, but I call it a waste jug, but that language seems pretty standardized. It's a stock pot. Okay, careful decanting, rinsing. Now he's using, I think, hot water there, perhaps. But look, he's pouring off the rinse now, and this decanting, it has no color. He's going to react this with ammonia, and that ought to turn a little fairly bright blue if there is copper present. No copper, so now he's ready to go. Okay, let's pause here. So he's accomplished two tasks at this point. He had to get rid of that filter paper. It's accomplished. He also had to get rid of whatever other salts were in there, whether it's copper or gold. He had to get that out of there. And now he needs his clean silver. So this is now clean silver chloride. That's on the left side of that arrow. And now to get this into metallic silver, he's first going to convert it into silver oxide. Silver 2 oxide, that's the stoichiometry of the salt. So we've come a long way, but we've got a little further to go. Now to do this, he's going to react this with sodium hydroxide, or lye. And what that does is I'm actually surprised. I'm not aware of this reaction. I'm surprised it works, but it reacts with the silver chloride to form silver oxide. And that's that dark layer that we're seeing in here. Silver oxide has a darker color. And so it looks worse, but it actually looks exactly like he wants. I will say when you mix chemicals like this, very often it's standard to have a stir bar in there. Maybe you're on a magnetic stir plate, but he's just throwing everything in, but he's definitely getting the reaction he wants. I'll say one more thing before we get going. Notice the level of that liquid. We're going to see that level change, and I'm not saying it's significant, but he's not just adding sodium hydroxide. He's apparently adding water as well. Okay, more sodium hydroxide going in there. It's going to continue to react. That brown color, it looks bad, but it's good. That's exactly what he wants, but it's not mixing very well. Oh, how's he going to mix this? What is that? Okay, this is hard to watch. If I were to do this, I promise you I would shatter that beaker. That's a glass beaker, and he has, in this case, this is an Allen wrench attached to an electric drill. And he's given it the what for here, absolutely. And it is effectively mixing. It's a very creative solution, but I would probably stick with the stir bar. I'm going to be in agony for the next few seconds. Okay, add some more. Hope it doesn't. Oh, no. Gotta mix it up some more. God, look at this. It's a two-hand job. He's banging on the light kit in there. Oh, my goodness, stop it. Okay, I will stop. At first, one, because it's painful. And two, notice that the liquid has risen up a lot in there. So not only has he added the caustic, the sodium hydroxide, but he's also added a decent amount of water. And he's putting a lot of force in there. Okay, so now notice this brown color. That's what silver oxide should look like. And so now he's at least partially converted his silver chloride to silver oxide, and he's ready to try to convert this into metallic silver. So how is this going to work? Well, I want to go ahead and show a slide here. This reaction is really very interesting that he's going to perform. So he has his silver salt, silver plus 1, that's oxidized silver, and that will be in solution to some degree. And he's going to react with glucose of all things. And that is not a standard reagent that you would think of in organic chemistry or inorganic chemistry for that matter. But what glucose does is it's going to convert the silver plus 1 to silver 0, and that is metallic silver. So silver has an oxidation number. It's going from plus 1 to 0. It is being reduced. So this is a reduction. Now, anytime you reduce something, something else has to be oxidized. And the glucose is being oxidized. So this reaction is shown at the bottom. So here is our glucose right here. And glucose has a functional group called an aldehyde in it. It's an aldehyde sugar. It's called an aldose. And when that aldehyde interacts with silver 1 ions, it gets converted to a carboxylic acid. And that is indeed an oxidation. It has been oxidized. As it gets oxidized, it reduces something else, and that is the silver. So glucose, in being oxidized, it performs the reduction. So glucose is an example of something called a reducing sugar. And this particular reaction involving silver ions and sugars goes back to a person named Tollens. who is a pioneer in sugar chemistry. And if you took a sugar and you didn't know what it was, you'd react it with silver ions and see if you got silver solid. And that appeared as a silver mirror. So sometimes people call this the silver mirror test. And that was a way to try to identify what your sugar was. And, here we are over 100 years later, and that same chemistry is now being used as a way to not identify sugars, but to convert silver ions into metallic silver. And actually, if you go online to different discussion boards, people talk about this exact chemistry. Okay, let's go back to the video. Okay, so here he's adding his sugar. This is glucose, just like we saw on the slide. And he's adding that in. Again, a stir bar and a stir plate will help. He's going to use, in this case, a stirring rod. Now, let's go back just a second here. Okay, so let me try to advance this slowly. That's pretty good. Okay, so just look at the color there. Let me try to go frame by frame. He's going to stop. So he's mixing this around. I'm going to take a second. Oh, bam. Okay, look. So look at that color. And the next frame, he does a cut to that one. It's starting to look a little bit silver. So in the narration, he's like, hey, not much is going to happen and let's add more sugar. But something is happening. It's not much, but you can see that color has changed. Nothing else in the frame changes color. It's just that. There is a chemical reaction. He is getting some of that metallic silver precipitating out, and you can see it in the color of the solution. So that's very cool. He's got progress. Exactly what he wants to happen is happening in here. Okay, add some more, stir it around. Yeah, look, it's even a little more silvery, I think, if you, well, I kind of missed that, but it's looking more silver. Now, it is apparently really thick. It's kind of a pasty mess. So he adds water, and it just pops and reacts. I don't know why that goes so crazy, but notice he has a lot of stuff in there. He has a lot of sodium hydroxide. He has, of course, his silver salts. He's thrown a bunch of sugar in there. He has all these reagents that aren't mixing well. And so he throws in a little water to get everything to kind of mix and mingle. And it does, and it reacts, and it frosts and kind of splashes out on him. Now, let's watch one more clip here. He kind of exclaims, wow, yeah, that was crazy. And it certainly was. And so now he's going to add a little more, and it splatters. So when reactions do this kind of thing, stirring is your friend, making everything homogeneous, and maybe adding this water drop-wise would help. But again, a magnetic stir bar, a stir plate, and drop-wise addition of water would just sort of smooth out some of the rough spots here. And it wants to go, and it's splashing out. Now I know he's got a lot of safety stuff on, but so he's showing that to reveal that the silvering that's forming on the side of that beaker. This is just like the silvering that people saw on the Tollens test. So he's doing some ancient chemistry here, but it's as relevant today as it was back then. Okay, I had to skip an ad. It was for Bounce Dryer Sheets and Cadillac, in case you're wondering. But anyway, let's get back to it. He's still trying to go with the water. It still wants, as it gets more dilute, it's a little less reactive. Again, just letting this mix around, gently mix that, and bam, that's what he's wanted to see. There is the silver precipitated on the bottom. So this looks great. Excellent, excellent stuff. So he's going to start to do some of this chemistry again. He's going to decant, drain off the liquid, rinse with more water. He's got a lot of stuff in there, a lot of salts. So he's going to try to rinse all those off. Fortunately, this silver is staying in the bottom of the beaker a little bit better. It's less prone to kind of spill out and wash out when he decants. Okay, that's looking good. Looking good. Now, how does he know when he's done? Well, he's really not done yet, but that's looking better and better. Look, that looked fantastic. Okay, so he's going to check his pH here. And I missed it. With that last rinse, he threw a bunch of hydrochloric acid in there just to make sure he was dissolving any unwanted materials in there. But it won't react with silver. So now he needs to make sure he's getting rid of all that acid. And he can use these pH strips. Now he's going to rotate it back. There we go. Okay. In the upper left column, you can see that's a green. That's green for 7. He wants pH 7. And let's see what the strips tell him. These are fantastically convenient colorimetric strips. So he's going to take this strip, and what's he going to do with it? He's going to drop it. I would say typically you wouldn't drop it in the beaker. You get a drop of the solution out and drop it on the strip, but that's okay. There's a stock pot. That looks gross. He's going to test his stock pot just to show that these things do work. The stock pot's full of base and it has a very high pH. Okay, and what's this strip look like? That looks a little acidic. Not surprising because he threw in HCl. So now he's going to do a little more rinsing, little heating, thermal encouragement, as I like to say. Sometimes that'll help make sure everything gets rinsed out. He does another strip, gives it a good dunking, okay? He's getting close. That looks like about a pH 6, but he wants perfection. You have to admire that. It'd be so easy to say 6 is good enough. Who cares? But no, he's going to actually do it again. He's going to do it right and get it to pH 7. And that looks good. That was that green color he was looking for. Now, before we move on, I will say again, if you wanted to rinse this material, it's a solid. You could filter that into a Buchner funnel and just do successive rinses of distilled water until the liquid that was coming off of the solid was neutral. So there are other ways you could sort of accomplish this same goal. But now he is heating this up to dry off all the excess liquid. Look at that fine metallic powder in there. And as it dries, it kind of falls off the side. That looks good. He's going to smash it up just to get it into a nice, less crunchy powder, something that flows a little bit better. And now he's going to do a little mid-roll commercial. That's okay. He's a jeweler, okay? He makes jewelry. And you can see this is some of his fine work. Listen, if you need a fancy ring like this, check out moderngoldsmith.com. I'm not afraid to promote his materials. It looks like beautiful materials. Okay, now we're back. Now he has this solid. It's a little more free-flowing. He can dump it into this crucible. And, I'll pause. He's been doing a lot of chemistry. He is not a chemist. I don't think he'd call himself a chemist. I don't think he'd be insulted by that. But now he's in his realm. This is what he does know how to do, and he's comfortable doing this. He's going to melt this thing down, and he's going to bend it to his will. Okay. Hits it with his torch. Again, there's music playing, so I just can't bring in the audio. So I can talk about the chemistry. I don't have a torch that'll do this in my lab. Nice stuff. And now as that's molten, now that looks like silver. In those fine granules, it didn't look like it. But that is silver, and that looks beautiful. He's going to get into a nice little button in the bottom of that crucible. And then he's going to let that cool down a bit. And he adds water. I didn't think you're supposed to do this with crucibles. That's kind of hot, but that's okay. He doesn't need my permission to do anything. And there it is. Okay, there is that button. So he got that silver button, that silver from that material. He's going to weigh it. Gets 25 grams. 25 grams is a little bit less than a troy ounce. And so, that's a pretty decent chunk of at today's prices, a troy ounce is like $42. So that's, well over $30 of silver. Nothing compared to the gold, but still, It's has some value. He got it from that mess. Look, that's gross. Copper, a little bit of gold, and there's his gold. That was beautiful. The gold sponge he isolated. And there, let's go back. So he's talking about, he didn't initially plan to go after the silver because he wanted the gold. And so he now wishes he maybe been more careful with the solution that ended up yielding the silver salts, because he might have spilled some. As you can see to the right, there's a little bit of spilling, but that's okay. He salvaged just a great thing here, getting this silver out. Okay, now we can let's turn on some audio. Play up for the rest. We're back in Breaking Bad mode. Flashing back to his orange juice.
It's unforbidden orange juice. One last toast to the blob itself. I also want to thank Nile Red and Sri Tips for their incredible...
So he mentioned Sri Tips as well as Nile Red. Sri Tips has tons of videos about refining, collecting silver and gold, refining those from impure sources. Another fantastic channel. I'll put that in the video description as well.
Helpful and informative videos. I really couldn't have done mine without them. Also, I'm so thankful to all you beautiful chemistry enthusiasts and people watching this. I got just so many kind comments and tips and recommendations. Go ahead and let me know.
Chemists aren't always kind. I bet some people said, "Hey, you're a knucklehead for doing X, Y, or Z." But that's just people. And before he cuts out, listen, I'm just going to stop there. I want to thank Modern Goldsmith for posting this content, for people to do a reaction video. I didn't mean to press the space bar there. And I want to thank you for your attention. So we'll play to the end, and then we'll wrap it up.
Like what kind of jewelry I should make, and I'll maybe do that in the next video.
Okay. Hey, fantastic. Thank you so much for your attention again. Everybody take care and enjoy the rest of your day.